Well, good morning. My name is Alex Sherrod. I'm with Precision Pipe and Products, and today we're going to discuss culvert slip lining and the InfraSteel rehabilitation solution. So, throughout the United States, there are millions of culverts that have exceeded their design lives. Now, some of these structures were built by mason and craftsmen over 100 years ago, while others have rusted or crumbled over time. And it's not uncommon to see news reports about failing bridges and roads that have collapsed into sinkholes. So, depending on their size, culverts or groups of culverts are often out of sight and out of mind until a road collapses or one of those sinkhole appears. So, this presentation again, it'll highlight the common factors that affect culverts, the growing market of trenchless rehabilitation, the InfraSteel system, and the significance of using time-tested materials for culvert and bridge rehabilitation. Our learning objectives today is first to define what is a culvert, what causes culvert failure, what are the visual signs of a failing culvert, what is trenchless rehabilitation, an overview of InfraSteel, the InfraSteel design and development story, a look at a few project case studies, a review of project considerations, and finally, Q&A. So to start off, we're going to play a video here of what can happen when your culvert goes without proper inspection. So what is a culvert? Well, when we hear the word infrastructure, most people think of roads and bridges. However, supporting those roads and bridges are countless drainage structures, most of which can be classified as culverts. So a culvert is a buried pipe, box, or arch structure that is open at both ends to convey water on a roadway or a railway. And culverts can be structurally similar to bridges, but are defined as having unsupported spans of less than 20 feet. Culverts can be of rigid construction, being made from steel, concrete, and stone materials, and which would be designed to handle all load pressures from surface traffic and surrounding soils. Or they can be made of flexible materials such as corrugated pipe. And this type of culvert interacts with the surrounding soils to meet loading requirements. So what is the objective of culvert rehabilitation? What is to take maximum advantage of the remaining usable structure in a culvert to build a reconditioned culvert with little to no impact on the roadway or traveling surface. So what causes culvert deterioration and failure? Well, one of the most common problems with culverts is deterioration of the invert, usually due to a combination of corrosion and abrasion. And continuation of this, if unchecked, will lead to loss of the invert and the creation of voids under and around the culvert. Since flexible culverts require interaction with soil for stability, loss of the invert may result in severe distortion or collapse of the structure. Additionally, rainfall, flooding patterns, snow melt, and other stormwater events can expedite culvert failure. The water is unable to flow through the structure, and headwater pressure exceeds its design hydraulic parameters. We can see from the picture here on the left a culvert that's experienced severe degradation on the bottom of the invert. You can see how that corrugated metal pipe has rusted and crumbled out. And over here on the right, we see a culvert that's got a severe flooding on the upstream side where this culvert is not displacing all that water efficiently. And again, these factors will lead to an increased likelihood that the culvert will fail if the structure is not inspected and documented accurately and regularly. So what are the visual signs of a failing culvert? Well, from what we just saw, first you might see excessive water backup at the upstream end. And in this instance, the ability of the pipe to carry the water is diminished. So where the barrel of the structure could be beginning to cave in or close up. Second, we may see roads settling and cracking, in addition to sinking guardrails where the roadway surface is beginning to settle over the path of the culvert. We may also see separation of the head wall. And if the culvert is not displacing water efficiently, headwater pressure may begin to force separation between the head wall and the culvert barrel. So the culvert would be beginning to float based on water movement. And this would indicate that backfill material around the pipe is beginning to erode or wash away, and could lead to the catastrophic failure where that culvert's completely washed out or washed away. So what is trenchless rehabilitation? Well, trenchless rehabilitation of culvert pipes take maximum advantage of the remaining usable structure so that the pipe is returned to its initial condition or better. Trenchless rehabilitation methods have less impact on the public since they can be done inside of the hose pipe and without the need to close down any of the roadway or traveling surface. And trenchless rehabilitation is appropriate when the culvert begins to lose its structural integrity but has not completely failed or collapsed. So the most common trenchless rehabilitation reline techniques include cured in place liners, which are flexible resin-saturated tubes that are pulled into existing pipes. And these are expanded with water or air pressure and exposed to heat or ultraviolet light to stiffen and cure. And that curing of CIPP typically takes 5 to 30 hours, depending on the diameter and the current site conditions. Second, we've got spray-on liners. And spray lining occurs when the structure of the culvert is sprayed with a variety of different liquid products. This reline method is typically less expensive, but does not provide the structural support of other slip line methods. Spray lining materials can include polyurethane and cementous materials. Next, we would have vinyl wrap liners, which use a specialized machine to install a spirally wound vinyl material into the hose pipe. You can see from the picture here where those sections would be fused together as they pass through the machine and inserted into the hose structure. And finally, we have rigid slip liners, which can consist of smooth wall steel, HDPE, or reinforced concrete pipe. So this new pipe material is pushed into the existing structure and would assume all water displacement and load-bearing responsibility. Pressure grout is commonly used to seal the slip liner in place, and InfraSteel is classified as a rigid steel slip liner. And an important aspect of trenchless rehabilitation is addressing the structural issues that arise from the failing invert. So when a culvert loses its invert, there are two things that happen. First, bedding and backfill around and under and around the pipe is no longer supported and is allowed to enter the stream of water. The water would wash away any material that can be dislodged. Secondly, because part of the circumference or hoop is gone, the pipe is no longer able to retain the soil in the position as it was engineered. So this first affects the ability of the structure to resist the weight above, and the circumference of the pipe begins to change. So from the picture we can see on the right, it closes in where the invert used to be and gets smaller. Second, paving of the eroded invert is typically a Band-Aid fix, as it does not properly address long-term structural issues. And as we discussed, most trenchless rehabilitation methods aim to rehabilitate the entirety of the culvert barrel. So now that we've discussed the common factors that lead to culvert deterioration and common trenchless rehabilitation methods, I'd like to introduce the InfraSteel system, which is classified as a smooth wall carbon steel slip liner. And this classification meets most state highway and roadway material specifications for steel pipe. So InfraSteel is a road, bridge, and rail culvert liner system designed to give cost-effective and environmentally friendly alternatives to infrastructure preservation and rehabilitation. And we work with project owners on the design and fabrication in order to ensure that InfraSteel delivers on the five following metrics. First, that it be cost-effective culvert rehabilitation solution. And when conducting a life cycle cost analysis for a project, it is more economical to slipline a failing culvert than to cut the road and replace it. So that would take into account all costs associated with detours, disruption to traffic, excavation and material costs, and construction timeline costs. InfraSteel's material cost is also competitively priced when compared to other rigid reline methods. Second, that it's environmentally friendly. So InfraSteel, with its steel composition and installation methodologies, is benign to the environment, as steel and concrete have been used for many years for road and bridge construction without contamination issues. Additionally, due to its steel construction, it allows for additional features to be incorporated into the design to assist in aquatic organism traveling through the culvert, among other features, which we will discuss here shortly. That it provides structural integrity. And with InfraSteel, each liner can be certified to AASHTO loading standards as a standalone structure. So with a minimum of half-inch thick steel plate, it is durable and long-lasting against corrosion, abrasion, impacts, and debris. Fourth, its custom shape would maximize hydraulic capacity. So matching the shape of the original structure, InfraSteel provides the maximum hydraulic capacity possible and limits the amount of necking down required for an effective slip line. And with a friction coefficient of 0.012, smooth wall steel also provides a greater flow velocity when compared to corrugated metal or concrete. And finally, that we're delivering on a 50 to 100 year life expectancy. So InfraSteel has a calculated design life based on the thickness of the liner chosen for each project. Once the load-bearing thickness is determined, steel is added to the thickness for each year of design life required, taking into consideration the added copper in InfraSteel for corrosion prevention. This copper content negates the need for any additional coating to the InfraSteel pipe. So now we're going to play a short video that summarizes InfraSteel's installation methodologies and performance metrics. So a little background on where we got today with InfraSteel. As a company, Precision Pipe and Products entered the trenchless rehabilitation arena first by working with the Virginia DOT to slipline degraded round corrugated metal pipe culverts with round steel pipe. And the state had a need for sliplining irregularly shaped and large diameter structures with a product that would provide extended service life, structural integrity, and not severely limit the area of flow. So InfraSteel was developed in order to meet the state's need and provide a long-term culvert sliplining solution. This has expanded to a national footprint where we strive to provide states, counties, and municipalities with a permanent culvert rehabilitation solution that utilizes proven methods and materials. As part of our design and research when developing InfraSteel, we went to the California Department of Transportation and referenced this 2001 study where they measured the performance of various culvert materials in an abrasive environment. And this research project was conducted to capture and evaluate the level of resistance to abrasion of the most common culvert materials and coatings. So it was conducted at a real-world test site, which you can see here indicated in the picture, where they evaluated 17 different materials over a 6-year period. These materials consisted of concrete, PVC, HDPE, steel plate, and common coatings for each. And more information about this project can be researched here at the Office of State Highway and Drainage Design in Sacramento. So taking a closer look at the data they recorded, the blue graph depicts the wear rate in millimeters recorded for each material type. And we can see that across the x-axis here. It was found that during the initial 5-year period from 2001 to 2005, smooth wall steel plate recorded the lowest abrasive wear. We can see steel plate over here on the left. And pipe made with calcium aluminate concrete had the highest over here on the right-hand side. And again, that's the wear rate in millimeters per year. In 2006, a large-scale storm event washed away 15 of these materials, leaving only the steel plate and the HDPE samples. And we can see here in the purple graph, the spike in abrasion during those heavy events of 2006. And it's important to note that this data shows us that eventually any coating can be eroded or broken away, applied to the ID of a culvert, and that abrasion can accelerate the corrosive conditions to the pipe. Abrasion wear is also weather and event driven and can vary from season to season. So Caltrans then had a follow-up study where they looked at the destructive resistance of steel pipe in corrosive soil, water, and marine environments. Taking a closer look here, the study recorded that steel corrosion rates vary depending on the environment, as indicated with a soil embedded zone, immersed zone in a marine environment, as well as a splash zone in a marine environment. And the significance of this study showed that steel pipe can be used in corrosive soil or water environments, provided that adequate mitigation measures are in place. And the department cited that sacrificial metal be incorporated into the design of the pipe wall thickness to compensate for the loss of metal that occurs due to corrosion. So this extra metal thickness should be added to all surfaces of the pipe that interact with soil and water. At InfraSteel, our design engineers used this type of data in order to determine the necessary wall thickness and sacrificial steel needed to achieve the desired design life. So as part of our design process, we first look at the wall thickness required to achieve the structural capacity or structural requirements of the structure, and then add in additional wall thickness to be utilized as sacrificial steel to achieve the desired design life, whether that be 60 years, 70 years, 80 years, 100 years. So as I mentioned before, InfraSteel's liners are designed to meet site-specific criteria. And steel allows for a multitude of design possibilities while providing long-term structural strength and durability. So these pictures show the variety of flexibility in fabrication and design, from elliptical shaped culvert liners to box culvert liners, and even here on the right-hand side, bell-shaped cattle pass design structures, which typically be utilized in a railway environment. So shaped designs can range from 36 inches to 20 feet in span. So there's really a large variety of shapes and sizes that can be designed and fabricated. Again, I mentioned that steel allows for flexibility in design, and really in working with our customers and partners, that drives innovation at InfraSteel. And so we're able to fabricate fish baffles and weirs to accommodate environmental requirements that allow for aquatic organism transportation through the culvert. In addition to some of these site-specific designs, such as inlet and outlet control features, which you see here with a beveled bell type inlet design, a beveled design here with reinforced head wall and wing walls. And then over here on the left-hand side, we see a liner that's actually designed for a natural bottom. And so this liner would slide into the existing structure and could be designed to sit on top of knee walls or a poured concrete footing so that the natural bottom would remain in place. And in order to accommodate an effective slip line, the InfraSteel liner is downsized approximately 6 inches from the existing structure's dimensions. So you've got roughly 3 inches of annular space between the existing structure and the InfraSteel liner. That would be filled with flowable fill or cellular grout once the liner is installed. And in order to accurately design and fabricate a liner that matches the existing structure, either the project owner or one of our team members would take field measurements of the interior dimensions and radial changes of the hose pipe to confirm the size and shape of the existing culvert and the appropriate liner. We would then produce a template, which you can see here. It's just sheet metal template that would be shipped to the site and assembled in order to confirm the liner dimensions will meet those site parameters. So the template would then be walked through the structure, confirming the overall design. And once this is confirmed, the liner would then be entered into production. So in addition to culvert rehabilitation, InfraSteel is also designed to rehabilitate short span truss and timber bridges. This application was developed through partnership with Class 1 railroad and freight carriers, and it can be designed to handle all loading requirements and slipped or dropped into place, minimizing your track or roadway downtime. You can see here we've got a before and after of this railroad truss bridge and the solution that was implemented to fully rehabilitate the structure. We're going to play another video that summarizes our bridge kit and railway rehabilitation capabilities. So what is the installation process? We look at it as a 3-step process for culvert rehabilitation that begins with cleaning and dewatering of the host structure. Bypass pumping or the construction of cofferdams are common methods to dewater the hose pipe. And we can see here a crew that's working in a dry environment as they begin the rehabilitation efforts on this culvert. Second is the installation of the slip liner that would include the welding or joining of the joints. And installation of the slip liner occurs by either pulling or pushing the liner into place, which is typically done with common equipment such as telehandlers, jacks, pulleys, or a track hoe. We can see from the picture here that InfraSteel is shipped with cross bracing on the inside of the liner, and that is left in place during installation to aid in liner section alignment. Also to keep the liner, help keep it shaped during install. So once the liner is installed, these are removed once the annular grouting has taken place. Channel iron, rebar, or metal runners can also be utilized in the bottom of the culvert to allow for a smoother gliding surface during installation, which we can see here. InfraSteel is available with shaped or conical lead pieces, which prevent the liner from getting hung up on bulges, hanging metal, or debris in the host structure, and helps facilitate a smooth slip line. And they can be removed once the slip line is completed. I want to mention here that each liner section, each section is shipped in an 8 to 10 foot length, and the ends can be beveled to allow for welding on the inside or the outside of the liner. And full penetration welds eliminate the possibility of joint failure. We can see here that a welding crew is working on the inside of the pipe to begin welding up these liner sections. And then over here with a liner that has a smaller ID, they're working on the exterior of the liner. We'll note that some field manipulation may be required to ensure that each liner section is uniformly abutted prior to the welding of the joints. And finally, the last step is grouting of the annular space. And grouting can be accomplished utilizing pre-installed grout ports in the top invert of the liner or by horizontal grout injection methods. Different slip line materials may require a specific grout PSI at the point of injection. I might have mentioned this before, but cellular grout and flowable fill are the most common during InfraSteel rehabilitation projects. Finally, we've got a great picture here of a cross section of a fully rehabilitated culvert where we have the installed InfraSteel liner, that layer of grout filling up the annular space, and then this existing corrugated metal pipe culvert did not have to be removed and was left in place. So now we're going to look at our first case study, which took place in Lawrence County, Tennessee. And InfraSteel was identified by the Tennessee DOT to slipline a deteriorating CMP culvert under State Highway 242. And Highway 242 is the main paved state access through Lawrence County. Maintenance engineers determined that sliplining was the best option for repairing the failing structure. Our team first met with TDOT in the summer of 2019 to discuss InfraSteel's capabilities and benefits as a smooth wall carbon steel culvert slipliner. Following that initial meeting, we conducted a thorough site inspection to assess current conditions and feasibility of a slipline rehabilitation. The CMP culvert located under State Route 242 measured 92 inches in span with a 61.5-inch rise, a total of 64 feet in length, and was located approximately 7 feet below the roadway. Initial inspection of the structure revealed that severe deterioration in the invert had occurred due to abrasive and corrosive factors in the environment, coupled with the length of time that the culvert had been in service, which was estimated to be 50 plus years. So once it was confirmed that the design liner would meet all site and project requirements, we fabricated that metal template and shipped it to the project site in February of 2020. So this template was assembled by the maintenance crews and walked through the structure, ensuring a proper fit and verifying no complications would arise once the lining commenced. The InfraSteel liner was then entered into production and shipped to TDOT's Lawrenceville maintenance yard. The liner shipped in 8 pieces, each measuring 8 to 10 feet in length, and they decided to weld 2 sections together in order to save on the number of field welds required at the project site. Here's another shot of the interior of the hose pipe with those existing conditions. And then over here is the submittal or the design drawing for the InfraSteel liner. So we see the existing dimensions of the hose pipe, and then the design lighter dimensions. And again, InfraSteel is able to match the exact shape of the existing structure, maximizing the hydraulic capacity possible and limiting the amount of necking down and annular space required for an effective slip line. So the crews cut and removed the deteriorated invert and prepped the existing structure by pouring a concrete slab and laying channel iron for the InfraSteel liner to slide over. We can see how they did that. Again, all that degraded and rusted corrugated metal pipe was cut out. This concrete pad was poured into place, and we can see the channel iron runners that were laid in the bottom of the structure for the liner to slide on top of. So once that concrete slab had cured, the InfraSteel sections were moved into place. A look inside of the liner shows that, again, shows that cross bracing, which is tack welded to ensure each section keeps its shape during transportation. And those would be removed once the annular space grouting was completed. So the end result here is a new structure that will continue to serve the volunteer state for another 70 plus years. Now we're going to watch this video that shows just exactly how the liner was installed at the project site. So the next case study we're going to look at took place in Onondaga County, New York. And our team worked with the New York DOT design engineers to rehabilitate a 77-foot culvert located here in Salina, New York. An interesting aspect of this project was that the indigenous Onondaga Nation consider the Onondaga Lake sacred. In addition, the residents of the area have enjoyed this park with its 7.5-mile linear greenway for many years. So the ends of the existing structure incorporate beautiful stone masonry, which we can see, and that was also an important aspect of the project owners to preserve. So here's an overview shot of the project area. Actually here on Highway 370 is where this culvert is located. And it was also important during the rehabilitation to maintain the profile view of the structural barrel, which had been lengthened and changed during past road widening construction. In order to do this, our design team faced the challenge of transitioning from a 234-inch diameter span at the inlet to a 174-inch diameter main barrel while navigating a 20-degree bend. We can see, kind of looking through there, the profile of the structure. We're going to look at this video case study summarizing the project. So this culvert rehabilitation was successfully completed without traffic interruption and maintained the structure's aesthetic qualities. The newly rehabilitated culvert will provide long-term service to the citizens of Onondaga County. We could see here again, that's a great shot showing the design reducer inlet and how we navigated that bend, transitioning from a larger OD to a smaller ID in the culvert barrel. So now we're going to talk about 10 factors to consider when determining your trenchless rehabilitation solution. And this is important for really any project owner to, to consider. First would be the flow capacity. So what is the supportable flow rate of the culvert under a specific set of weather and site conditions? And is the rehab solution going to be able to meet that? Second would be its design life. What is the period of time for which the alternative solution is estimated to maintain structural integrity and function as designed? Third would be increased structural integrity, or the ability of the rehabilitation method to increase the overall structural integrity or strength of the culvert. Its adaptability, or the solution's ability to be expanded upon or altered in the future. Total estimated cost of the solution, which include contingency and design fees, as well as materials and construction costs. Its environmental impact. What impact does the solution have on the surrounding environment and waterway area? Community and traffic disruption, or how will the rehabilitation method impact traffic flow, business operations, and daily life of the community? Estimated construction time, essentially how long will it take to complete and implement? It's permitting difficulty, the amount of difficulty and labor related to obtaining proper permits for the solution's construction. And finally, contractor availability, or the overall ability of relatively local contractors to install the rehabilitation solution. So if you visit our website at infrasteel.com, we actually have a free culvert rehabilitation product evaluation spreadsheet available for public use. So by entering in your contact information here, this would be sent straight to your inbox, and it's an Excel spreadsheet that utilizes those 10 factors we just discussed to give an unbiased evaluation of various rehabilitation techniques and materials. Also note that a new feature on our website is our blog section, and you can access that to look at industry-related topics and discussions. So I'd like to summarize that InfraSteel, again, is an environmentally friendly and cost-efficient alternative for culvert rehabilitation and preservation. My name is Alex Sherritt. We've got, again, the capability to rehabilitate culverts, as well as truss and small span bridges, anywhere from 36 inches to 20 feet in span and shapes, as well as large diameter round shaped structures. My contact information is listed here, and I'd like to thank you all for joining me today and for your time.